Hello and welcome back to my third video of the 8080 assembly programming series. Today I want to start diving into some data structures in assembly, and one of the most used ones, especially in C, is the struct. So let's do structs in 8080 assembly. This is actually very straightforward. Structs allow you to do many things like linked lists, objects, and ultimately we'll be going from structs to linked lists to malloc and free. And once you do malloc and free in assembly, it's kind of free game for you for programming. Anyway, let's get into it. So let's do some pseudocode here, or some C code here to figure out what we want to do. So we want to do struct, let's call it foo, right? Let's have three things in here. So char A, let's do byte B, and let's do int num. Now remember, ints are int 16. Because that's just how it is in 8-bit systems. You can have a 32-bit int, but through the Aztec C compiler, ints are 16-bit because that's the largest number you can have in a in a 2-byte wide register like HL or BC or DE. So there we go. Now how do I put this into assembly? Now, if you recall from C, you have to make a struct, but you can't assign anything to it. You make the framework first, and that's exactly what we're going to be doing. So we're going to make the framework. So we're going to call foo equals, we're going to do a bunch of equates here, foo, and down here we're going to say foo is a bunch of bytes. And how many bytes will this be? Well, this will be 1 byte, 2 byte, 3, 4 bytes. So we need 4 bytes. Okay. And then there are many ways of doing this, but let's just do it this way first. Foo A equals foo, because char A is the first thing on the memory address. Foo B is equal to foo plus 1, because it's 1 byte down. And then we can say foo num is equal to foo plus 2, because it's 2 bytes down. 1, 2. And here's the integer. Now there are do whatever you want to do, but you could also do something like this. You could also do something like char is 1, byte is 1, and then int is 2. So then you could say something like this plus char, and then you can say foo num equals foo B plus byte, because what's happening here is you start foo A equals the first memory address. You could then say foo B is foo A offset a char, and you could say foo num is foo B offset a byte. So there's many ways of doing this, and there's no real right way to do it. Just up to you. Anyway, that's how you do a struct. Now, of course, with structs, as in C, you can declare a struct, but like it doesn't do anything. You have to set it. So then you could use memcopy or stuff like that. Let's see if we can use one in a program. Okay, and that here is structs in 8080 assembly. Now, I did have to like do some weird stuff here. That's most likely just the figment of the CPM assembler. If you use a better assembler, it's probably not going to be this way. You can probably do forward references to labels and stuff. Why it's not working right now, I don't know. But that's really it. That's all you got to do. And I'll see you in the next one.